Hi, everyone. I'm David Bamman from the School of Information at UC Berkeley. And what I want to do with these short 15 minutes that we have is introduce you to a new resource that my group has been building for the past year or so that's really designed to make natural language processing work better for literary text. This resource called LitBank was really designed around this basic observation that a lot of work that is in this intersection of NLP and the humanities or social sciences is really treating NLP as a kind of algorithmic measuring device that involves a pipeline of different steps. These steps include tokenization, part of speech tagging, NER, and so on. And if you look at the state of the art for a lot of these individual components, you'll see that the state of the art for them is actually quite high. Right, so tokenization by construction is about 100%. Part of speech tagging is now up to about 98%, NER 93.5. Syntactic parsing, phrase structure parsing is now up to 96.4. And co-reference resolution is all up to 79.6. Right, a lot of these improvements are due to the rise of contextual language models. We've seen a really stark increase in performance for a lot of these different tasks in NLP. But one of the dirty secrets that we have in NLP as a community is that a lot of our efforts are really focused on a very narrow set of domains. So the state of the arts that we see here can be relatively misleading, right, in terms of how well these models that are optimized for news are going to perform on other domains like literary text. And in fact, if we look at how attention has been allocated in the space of the NLP community, it is true that we have a lot of attention being given to news, to other domains like Twitter and product reviews, including the longer tail is where you see more attention being given to languages like French or Mandarin Chinese. But what we care about is the really long tail, right? The specific idiolects of writers like Mark Twain. Right, we want to have a model for all of these individual components work well on all of these individual authors that we care to analyze through the lens of NLP. So the problem with a lot of this is that when we take a model that's been trained on one domain like news and use it to parse or tag texts that are in a different domain like literature, we always see a very stark drop in performance. So this is true for part of speech tagging, moving from the Wall Street Journal to Twitter. A model trained on the Wall Street Journal, evaluated in the Wall Street Journal, gets an accuracy of 97%. Take that same model and use it to tag the parts of speech in Shakespeare, and we have an accuracy of 81.9, so a huge drop in performance. The same thing holds when moving from modern German text to early modern German text, moving from the Wall Street Journal to Middle English, moving from news to Dante in Italian, moving from the Wall Street Journal to Twitter for part of speech tagging and for NER, and for moving from across different domains for phrase structure parsing as well. So from the Wall Street Journal to medical text, Wall Street Journal to patent data, and Wall Street Journal to magazine data. Right, across all of these different domains, we see a huge drop in performance when we take a model that's been trained on one domain and use it to evaluate on another one. So there's a lot of different things that we could do to make this better. And a lot of the work that my group has been doing has been trying these different methods across a couple different dimensions. One is domain adaptation, right? To take a model that's been trained on one domain, give it a little bit of data from the target domain and try to tweak those parameters of your model to actually work well in the domain that you care about. The rise of contextualized word representations have been great overall, but also advantageous for this kind of cross-domain work because in principle, they're designed to give you representations of words that are sensitive to the much larger corpus on which you're estimating the word representations and not just on the specific data set that you have supervision for a particular task. But if what we care about is to have our methods work well for literary text, one of the things that you can do, right, that we have done is simply create more data in the domain that you actually care about. So what we've done with LitBank is create a new resource that's about 200,000 tokens big, all drawn from 100 different novels that we've annotated for 4 different phenomena: entities, events, co-reference between those entities, and all of the speakers for the quotations that are attested. All of this data is up on GitHub right now, and I encourage all of you to go and use it however you like. I'll give a link at the very end of this talk. But what I want to do for the rest of my time here is focus on 2 aspects here, 2 of these phenomena. entities and events and talk through how having literary specific, born literary data for these phenomena is really useful for having models that we can trust. And then also talk about a couple of different applications for using models to learn something about the space of literary theory, literary history. So let's talk about literary entities first, right? So entities come in a lot of different categories, right? People, places, organizations are classical entities for named entity recognition. There's been a lot of work in the computational humanities and cultural analytics more broadly in thinking about the ways in which character can be modeled using these kind of computational techniques, right? Using NLP again as a kind of algorithmic measuring device. And in that sense, what we need to have from an entity recognition model are all of the mentions of people. Right. And the current work that people tend to use right now for modeling character is drawn from the book NLP software that I wrote years ago that really extracts only two different kinds of entities. Proper names like Tom and Tom Sawyer, and pronouns, right? The he, him, his, and in this particular case that are co-referent with this particular entity. But we know that there's a lot of other kinds of references to these entities that really matter for getting our representation of character right. Not just proper names, not just pronouns, but the long tail of other common entities that also refer to the same individual. Right? So Tom Sawyer is also known as I when he's speaking, you when somebody is speaking to him, that boy, the child, the boy, the lad, and so on. Right, we really want to be able to capture all of these different possible reference as entities of their own in order to get a good representation for him. So if we want to get at this level of representation, that means we need to change our style of representation away from the flat structure of named entity recognition, right, which doesn't allow generally any kind of hierarchy, into a nested entity framework where we're labeling spans of text that correspond to categories of entities, whether they're named or not. So a sentence or a phrase like the elder brother of Isabella's husband, in this case, in this kind of formalism, really describes three different entities: Isabella, Isabella's husband, and the elder brother of Isabella's husband, right? All of them nested within each other. So what we did in this case was annotated data, right? We drew 100 books from Project Gutenberg that are drawn from a mix of different literary styles, ranging from the high literary works of Edith Wharton and James Joyce to popular pulp novels like H. Rider Haggard and Horatio Alger. For all this work, we selected the first 2,000 words from each text in order to label all of the entities that are within that sample of text. And we focused on 6 categories, the 6 categories that are mainly represented in other work focused on news that was carried out about 15 years ago, the ACE 2005 data set. So here we have different categories, including people, named people like Jarndyce, common entities like my mother. Facilities are structures that are built by humans, so that includes the house, the room, the garden. Natural locations like the sea and the river. Geopolitical entities that include not just named cities or named entities like London and England, but also other entities that have geopolitical organization like the town or the village, vehicles like the ship, the car, and organizations like the army and the church. So one thing we can ask here is if we needed to carry out this exercise at all, right? Do we need to annotate data within literature for capturing these different phenomena? To do this, we examine how well we can find these kind of entity mentions in text as a function of the training domain. Again, understanding what that impact is of having the domain be one that is within this specific target that we care about modeling. So to do this, we took a state-of-the-art model at the time for this work, a layered bidirectional LSTM with a CRF layer on top of it that from Ju et al. 2018, and then evaluated the performance difference for this model when we alter the training in the test domain. And what we found out here was that if we took a model that's been trained on news, on ACE 2005, and evaluated on news, we end up with an F1 score of 68.8. Right? This is state of the art for this particular data set for this particular problem. If we take that same model trained on news and use it to tag literature, what we find is that our accuracy plummets by about 25 points. Right? So our F1 score on this new literary data is now 45.7. So again, we knew this was going to happen. We see this happen across all sorts of different cross-domain work. Here we see it really catastrophically make this kind of model effectively unusable for our task. If, however, we take a model and train it on our literary data, evaluate it on a held out portion of our literary data, we see our accuracies go back up to the levels that they were at when training on news and evaluating on news. So in this case, going back up to the levels of 68.3%. And in fact, if we also change this model by making one slight difference here, swapping out static word embeddings for contextual word embeddings, what we see is our F1 scores, again, dramatically increase up by 9.3 points, right, up to 77.6 for an F1 score. So BERT, these kind of contextual language models really are the real deal at incorporating a new kind of information that these other models just previously did not have access to. So having this kind of data is useful for being able to recognize these kind of phenomena within this domain well, right? Being able to have this kind of data overall was really important. So those are entities. Let's also talk about events. And there's been a lot of work on modeling events, both within the space of NLP and within this broader philosophical tradition, right? So people have been thinking about events all the way back to Aristotle, and more recently, even in the context of linguistics from Davidson and Doughty. In our case here, what we want to do is adopt a perspective that is realist, right? Events are things that happen. Right, that happen in two people in particular, but also just happen whether they're depicted in news or in some imagined space like a narrative. In this view here, what we want to focus on in our case are what we're calling Realis events. Right, these are events that are asserted as actually occurring at a particular place and time. Importantly, these are distinct from other kinds of epistemic modalities. So we don't include future events here or hypotheticals because they're not depicted as actually occurring yet. And they're also distinct from other extra diegetic summaries by a narrator, right? So if the narrator is just popping out of the narration to offer their own perspective on things, we also treat that as an event that doesn't happen within the narrative space of that novel. So there's a couple of ways that we can break down this notion of Realis events according to a couple of different dimensions. Polarity is one. So if we have a sentence like John walked by Frank and didn't say hello, in this case here, we see an event, walked, that is depicted as taking place, but also another event, saying, that is not. The walking happened, but the saying did not. In our case, one of these constitutes a Realis event, one doesn't. Tense also is another dimension. So I walk to the store and will buy some groceries. The walking here is depicted as actually taking place, but the buying has not happened yet. Right? It's not depicted as actually occurring within this particular sentence. Specificity also speaks to another dimension here that's important for Realis events. Specificity here is this notion that a specific event has a singular occurrence at a particular place and time. Right? It happens to a specific individual, while a generic event is more a claim about groups or abstractions. So if I say, my son just watched Frozen, that is a specific event that happens to a specific person of my son. While if I say kids like Frozen, that counts as a generic event. One of these is depicted as actually happening as a real event. The other is a claim about a group and an abstraction that we say is not quite the same thing as a specific event. And finally, modality is a final dimension here that we can think about. I walked to the store to buy some groceries. Again, the walking is depicted as actually taking place, right? It is asserted in this particular modality, while the buying is not, right? The buying expresses the intent, but it's not actually depicted as actually occurring within the context of the sentence yet. Modality has a number of different ways in which it's expressed in language. So beliefs comprise this dimension of modality. Rumors of my demise, for instance, this demise has not actually happened yet. Hypotheticals, if you visit Rockridge, the visiting is not asserted as actually happening. Commanding John was ordered, that is asserted as happening, to return the book or face of fine. The returning has not happened yet. Threats, desires, and so on. Lots of different ways in which we see hypotheticals and other kinds of modals being expressed in text that aren't the same as them depicted as being taking place. So again, we took this same portion of text, 100 books from Project Gutenberg, annotated the first 2,000 words from these texts for all of the events, the Realis events that are depicted as taking place. And again, what we can ask here is how well we can train models to recognize these Realis events as they show up within these kinds of narratives, right? We have these two different sentences. My father's eyes had closed upon the light of this world 6 months when mine opened on it, and call me Ishmael. Only one of these sentences has Realis events depicted, and that's David Copperfield. Because in this case here, the closing, the father's eyes closing happened, my eyes opening happened, but the act of calling me Ishmael, right, this imperative, this command, is not an event that is depicted as happening within this narrative. So what we want to ask here, again, is can we detect events that have occurred in the space of a narrative? We tried, again, a couple of different models for being able to recognize these event triggers as they show up. The simplest thing that we could do is just identify every verb that shows up in a text as being an event. Right? This provides a reasonable baseline for us to be able to understand how well our models are performing. And if we do this, what we find out is that we end up having high recall because many events are verbs, but not all verbs are events. So the precision is low. Right? This ends up with an F1 score of about 28%. And importantly, also, we can see that not all events are verbs, right? Because this recall is not 100%. We have many events that are depicted as nouns in other parts of speech. To build on this, we trained a neural model, a bidirectional LSTM with a CNN on top of it for the document level, and a subword CNN that gives us a representation for words, even if we don't have embeddings for them. Use word embeddings learned from 15,000 Project Gutenberg texts, along with a sentence level CNN. That model dramatically performs much better than this simple baseline, getting an F1 score of about 65. But again, if we take a simple change here to use contextualized word representations from a BERT-based model as our input to a bidirectional LSTM with no fine-tuning for BERT on this domain or this particular task, what we end up having, again, is a stark improvement over this otherwise neural model. So again, having an F1 score here, which is now about 72. So again, BERT really helps with this kind of phenomenon. But again, we can see here that we can, in fact, recognize these Realis events as they show up with reasonable accuracy here compared to this very simple baseline. So what can we do with these kind of models, right? With the models that we are learning from LitBank for events with their co-reference, along with the entities that exist within them. One question that we can ask are what the markers of textual prestige are, or the textual signals of authorial prestige. A number of people have examined this computationally over the past couple of years, including Mark L.G. Hewitt, Ted Underwood, and Andrew Piper. In this case here, we can draw on this, all of this work really draws on this work by Bourdieu, right? And thinking about these different dimensions of prestige according to how they're being envisioned in the context of their level of consecration. Prestige in this work varies according to who's working on it. So Mark L.G. Hewitt defined prestige as inclusion in the Oxford Dictionary of National Biography, whether an author shows up on Stanford exam lists for English in particular. Underwood defines prestige as being reviewed by elite literary journals. So in our case here, what we use were the 100 authors identified in Underwood's work with the highest and lowest prestige, as measured by the number of times their works were reviewed by elite literary journals. This ends up with 150 high prestige novels, 188 low prestige novels. And we simply examine the relative frequency of these Realis events normalized by the number of tokens within these two different categories. And what we found was interesting, that the texts that have this label of high prestige, of being reviewed by elite literary journals, end up having fewer Realis events than low prestige novels. And the difference here is meaningful, right, just in this sort of base relative frequency across these two different dimensions. But the more interesting thing here that we observe is that not only are high prestige novels, not only do they have fewer Realis events, not only do low prestige novels have more Realis events, but they also tend to have less variability in depicting them. While high prestige novels here end up having much more flexibility in how many events they put on each page. Here you can see that the novels that we have in our set range from 2 to 7 events per per 100 tokens. Low prestige novels tend to have a much higher threshold for this, right? Moving from only 4 to about 6. One way of understanding this is that low prestige novels have less variability in depiction of these Realis events because something is always happening, right? While high prestige novels may have other ways of retaining the kind of reader's attention, low prestige novels end up having more pressure to have something always be happening in the context of that page. So this here gives us a sense of what we can do with Realis events. I'll only give you a reference to other work that we've published more recently at EMLP this year. Let's look at the entire pipeline of what we can do with LitBank when we use entities, their co-reference, along with the specific quotation attribution that we can do in the context of these models to understand how information propagates through implicit social networks that are derived from these kind of narrative texts. Here we are extracting the characters, building a social network from them, operationalizing information according to who is saying what in these novels and who they're saying it to, and then measuring discrete acts of propagation when character A says something to character B and character B says that same thing to character C. If we do this, we understand really interesting dynamics about how information flows through these kind of networks, along with the specific properties of those information bridges. I'll just leave this up here as a citation if you want to read that work on your own. So I haven't talked about co-reference. I haven't talked about quotation attribution, but both of these are also phenomena that we have encoded in this LitBank data set for this same set of 2,000 words from 100 different novels. All of this data, as I mentioned, is up on LitBank right now. And I see that I'm already over time, so I won't go on much further, other than say thank you. And to let you know, too, that while our work for LitBank so far has been focused very much in the public domain on text published before 1923, we are right now expanding that to include works published between 1924 and 2020. That includes works that are Pulitzer Prize winners and nominees, bestsellers, works in particular written by Black authors from the Black Book Interactive Project, 100 works of genre fiction, and 100 works of global Anglophone English as well. So not just works from the North American or from the UK, but from the Caribbean, from India, from China, from elsewhere, written in English. So with that, thank you.